Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Inversion Space is a company that focuses on creating autonomous re-entry vehicles to deliver cargo from space, aiming to make space a transportation layer for Earth. They're known for their capsules such as Ray 1 and ARC, which are designed for technology maturation and fully autonomous global delivery, respectively. The company was founded in 2021 and went through Y Combinator, securing funding from various partners. Joining me today on the Ex Terra Podcast is Justin Fiaschetti, CEO of Inversion Space. And Justin, thanks for joining me today.
Yeah, thank you for having me. Excited to chat.
Let's start just kind of from the basics and talk about how Inversion Space plans to impact the current space commerce industry with this autonomous reentry vehicle concept.
Yeah, absolutely. So I think an important starting point here is looking at where the market is currently, right? Some of the very big value generating space companies are focused on serving terrestrial markets, right? Whether that be Starlink with serving the internet market on the ground, or any of the imaging companies that are focused on taking pictures for use on the ground. For Inversion, we basically asked ourselves, hey, what if we can use the same value that space provides those platforms for delivering cargo, right? And that value is very much about covering large geographic areas with very little infrastructure on the ground. And so at Inversion, our goal is to be able to make it so that humanity can deliver cargo to anywhere on Earth in under an hour. Basically taking that transportation modality that happens on the ground right now, whether it be through boats or aircraft or rail, and adding a layer on top of that that's faster, has less infrastructure, and can allow for full global reach without any terrestrial infrastructure.
So how does that then kind of work into the whole idea of hypersonics, which are being talked about so much now for being point-to-point transportation in an almost suborbital kind of scenario?
Yeah, absolutely. Well, so hypersonics are like an interesting breed of technology, right? Where you have to take off from somewhere and you have to land somewhere. It's effectively a faster airplane. At Inversion, what we're focused on is storing the cargo in space, basically warehousing cargo in orbit that it stays there for long durations. And then when you need it, you can bring it down. And so we think of ourselves almost more like a warehousing company that has the ability to quickly get that cargo to where it needs to go, rather than a regular transportation methodology. As it stands, hypersonics have to be stationed at some airport, right? They have to be refueled, they have to be continuously maintained, and they still have to take off and go to the place they need to. For us, once we're in orbit, we just stay there.
So then kind of give me a basic scenario of how that might work. I mean, you say you're like, I'm going to say an Amazon delivery warehouse in space, and you've got all these things. First of all, who are the kinds of clients that you think are going to want to store items like that in space? And we talked with radiation team people about a week ago on the podcast. And so you have this radiation issue that you've got stuff that your materials now being exposed to, et cetera, et cetera. So how does it know what to go up there? Or I guess the capsule lives there on the warehouse with everything else? Yeah.
So I can kind of explain the concept of operations.
Okay, sure.
From end to end, and that I think we'll cover this. So we're building the reentry vehicles that also operate as spacecraft. So they're independent. We deploy them into a distributed constellation. So each vehicle, each capsule is separate from the other. And by deploying about 30 capsules around the globe, we can have full global coverage. And so each of those 30 capsules will have the same cargo, right? So it's basically a distributed warehouse around the globe. And that allows us to pull one of those down to any point on demand. And the kind of fundamental value here is reach and speed. Right? Where do you need to get to remote areas? You need to get there quickly. So some of the cargo, as examples, is things like medical supplies, right? Being able to deliver medical supplies to wounded soldiers, being able to deliver emergency equipment to lost hikers or shipwrecks, or anything that needs broad access and get it there very quickly. The military is a really interesting place for us, right? Whether that be deploying sensors or drones quicker than any other way that can happen. And so what we envision is thousands of these capsules basically layered on top of each other in constellations, so that you can have a selection of cargo to be able to pull down whenever needed.
So it's not like if I wanted to order a widget from Amazon and suddenly it's in your warehouse in space and it's parachuting down into my backyard in 20 minutes.
So not today, not today. Eventually, I think that's possible. If you look at the fundamental cost increments, assuming full reusability of both our capsule and rockets, it's the same cost increment of going from shipping with a boat to shipping with an airplane as it is from shipping with an airplane to us. And so anything that values speed and can pre-plan what is going to be needed, we can do that. Right, just as Amazon will project the amount of supplies that they're going to need to store at local warehouses around the country, they'll likely do the same thing here. Right, and now that's a little bit further out. We're focused mainly on national security and emergency and disaster relief applications to start.
Are you building your own rockets as well?
We're not building our own rockets. There's a fantastic ecosystem today of launch providers. Obviously SpaceX, but a lot of up and comers like Blue Origin, Relativity Space, Firefly, ABL Space Systems that we're able to launch on any of them. Right. I want to be launch vehicle agnostic. Right. Just like I want to be the shipping container, and we'll let the rail companies deal with that.
So, Justin, what are some of the challenges you face developing technology for space-based cargo delivery?
Yeah, so we are both a spacecraft, right? We have to stay in space for 5 years. We have to have solar power. We have to communicate with the ground while we're in space, and a reentry vehicle, right? That has to be very precise in its landing. And so, in space is a relatively solved technical problem, but precision landing of a reentry vehicle is not the most frequently done thing in the world. And so we spend a lot of our time and focus on the autonomous landing side of things, being able to land within 15 feet of our intended target, right? If I can land medical supplies directly next to someone that's wounded and make sure I don't hit them is a key thing. That's really powerful. If I'm landing multiple miles away, that cargo becomes a little useless. So the two things we focus on are the autonomous landing and getting to the ground quickly, right? The faster I can get this cargo delivered, the more effective it is, right? If it takes me 2 hours or 3 hours, I might as well just fly an airplane, do that. But if I can start getting the cargo there in 30 minutes, right, 45 minutes, now it starts to have an outsized value for the customer that we're delivering to. And so from a technical standpoint, each of those have their different challenges. So autonomous landing, right? Perception, right? How do we know where we want to land? How do we know what we're landing in, right? Whether it be water or solid ground. So we do a lot of computer vision to identify specific landing locations, identify where there might be obstacles to avoid, and then also understand how we can actually fly our trajectory properly to softly touch down under our parachute right next to where we need to be. And then on the speed side, right, how do you get to the ground quickly? Well, that's all about aerodynamics. That's all about how fast can you get through the atmosphere. And so we've designed the aerodynamics of our capsule to be more like a space plane, like it's a cross between a space plane and a regular space capsule. We haven't revealed the full geometry yet publicly, but it's going to be really exciting when we do. It basically allows us to cut through the atmosphere, be highly maneuverable, and get to the ground super quickly for our customers.
So a little bit like the Sierra Space Dream Chaser kind of lifting body, but also something that lands with a parachute near where you want to be, so you don't need a runway.
That's right. Yeah, flexibility of where you land is critical. And when you eliminate the need to land on a runway, you actually eliminate a lot of the technical complexity that Sierra Space has been running into with their Dream Chaser vehicle of having wings that fold out, having the thermal protection material on that leading edge, which is incredibly difficult, right. Having stability issues during the reentry portion of flight. So we think we've been able to eliminate a decent amount of the major technical complexities of a space plane while allowing us to have the maneuverability that those offer.
Tell me a little bit about the inception of Inversion Space and what inspired you to start the company.
Yeah, absolutely. So, I've always loved building things. Started woodworking when I was in high school, became a master woodworker by the time I was 18. Went to college for mechanical engineering, decided, hey, like if I can build tables, I could probably build things with math on them, right?
Mm-hmm.
And met my co-founder the very first day of college. We sat next to each other at the matriculation ceremony at school. And he's also a mechanical engineer, Austin Briggs. And Austin and I, we ended up finding the rocket propulsion group at our college. Fell in love with aerospace and everything like that. We designed a couple rocket engines together. I then went to SpaceX and relativity space. He went to ABL Space Systems, both working on propulsion. And we were talking one night during the pandemic after dinner. We were living together, and we were like, okay, like there's got to be more that can happen in space, right? Like at the time, it was like the two business models were like imaging and internet. And we were like, there's got to be more. And that's kind of how we stumbled on like, oh, well, the main value of those businesses is covering large geographic areas with very little infrastructure for a terrestrial market. And we asked ourselves, okay, what else is that useful for? And what we realized was, hey, what if instead of transferring bits back to Earth, right, information, you could transfer atoms, and you could use that same capability. And immediately we realized, wow, how incredible would it be if you could drop cargo anywhere on Earth in under an hour, right? And we immediately saw the application set of military, natural disaster relief, and we decided to jump right in. As we've been building the business, what we've found is that when you build a really great reentry vehicle, you also build a really great spacecraft. And so what we're able to do is host a lot of cargo inside of our vehicle, whether that be for technology maturation or testing components in space. And we kind of went through Y Combinator with those two aspects of our business, and have been excited about how we've grown ever since.
Let's talk about Y Combinator just a little bit and talk about how the funding and support from those types of organizations, Y Combinator, Spark Capital, how have they moved your business forward?
Yeah, absolutely. I mean, listen, we're a hardware business, right? And so you can't do anything without money at this stage. What we've been very focused on, though, is using the venture capital dollars that we get to allow us to go and capture funding from the Defense Department, NASA, those kind of organizations, right? How can we leverage the capital that we get to go and get revenue from customers? And so what we've done mainly with the money that we've raised is built our first vehicle, Ray. And Ray will be launching for the first time in October. We've been very focused on capital efficiency. For just our seed round, which we've announced was a $10 million seed round. We built basically everything on the vehicle. Everything from the parachutes, which are almost never built in-house for a space company. In fact, we're the first space company to build our parachutes in-house. The propulsion systems, the aerodynamics, the software, guidance, navigation, and control, the structures, nearly everything of the vehicle is built in-house because we want to have that vertical integration. And so capital from the venture capital community allows us to accelerate what we're building and bring that to market faster, right? A lot of defense primes, they're hesitant to spend money on research and development in new markets, right? And in new products that the government hasn't explicitly asked for. Right. But it turns out that the government doesn't exactly know what they want a lot of times, or they can't necessarily see 10 years in the future from a technology standpoint because they're not necessarily on the ground working on that. And so by seeing in the future of, okay, here's what is possible with today's technology, and here's how what the customer wants generally, which is faster and broader access and reach within the world, we can kind of merge those two to build a product that wouldn't be conceptualized by a defense prime. And I think that gives us a Inversion an advantage, but also the U.S. an advantage in the world of being able to innovate faster than anyone else because of that public-private kind of partnership.
Share with me, if you would, some of the company culture at Inversion Space and what you look for in your team members other than just extremely well-qualified engineers.
Yeah, I always joke that's like everybody always says they have the best engineers. And so like somebody's lying or somebody's not right. So I always say our team is from a technical perspective is incredibly well qualified, right? We have a parachute engineer who put a parachute on Mars. We have a guidance, navigation, and control engineer that was on the original team for landing Falcon 9, and everything in between. But the important part for inversion is, are they the right fit, right? Can they operate at a startup? Can they operate in an ambiguous environment where we're not giving asks on a day-to-day basis. We're saying, here's the objective, right? Let's go after it together as a team. And so what we focus on is, yes, you have to have the technical capability. That's a non-starter otherwise. But the thing we screen for when we're interviewing, and obviously who you hire is what your culture is ambition, creativity, and the ability to operate in an ambiguous environment. Because startups are not like even SpaceX, right? SpaceX has a clear path. You have infrastructure around you. At Inversion, we have to build all of that, right? We have to build the documentation processes at our company. We had to build that, right? At SpaceX, if you go and work there, great, it's already done. And so our team is like by far the most efficient team in the industry. I can confidently say what we've been able to do with just 25 people. Rivals things that companies do with literally 1,000 people. And I think that comes from the culture of focus, the culture of everybody being empowered to make decisions and move forward, right? Knowing that no one else is going to make that decision for you. One of our company tenets is we eat what we kill, right? No one's going to go and get dinner for you, right? You're going to have to go collect the berries, hunt the rabbit. Otherwise, we're not eating. And I think that's an important part of the startup journey is maintaining that hunger for success and that hunger to build something and change the world.
My guest is Justin Fiaschetti, CEO of Inversion Space on the Ex Terra Podcast. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Justin, with the upcoming test of your space-based delivery tech this October, which you mentioned a few moments ago, what kind of expectations and goals do you have for the mission?
Yeah, absolutely. So our October mission is all about technical development. It's all about testing our technology and learning from it. And we've designed the mission to be end-to-end, right? So we'll launch on SpaceX's Falcon 9 Transporter 12 mission, which is launching no earlier than October 1st. Then we'll separate from the vehicle. We'll stay in space for a few weeks. We'll do all of our solar pointing to charge our batteries. We'll communicate with the ground. We'll monitor the health of the vehicle. Might take a few pictures while we're up there. And then assuming all of that goes well, we'll go ahead and start our deorbit process. And that happens when the weather is clear at our landing site and our orbit aligns with our landing site. At which point we'll fire a rocket engine to start to slow the vehicle down. It's about an 8-minute burn that slows the vehicle down enough that we start to enter the atmosphere.
Right.
After the end of that burn, we ditch the propulsion system and the capsule comes back. The propulsion system designed to burn up on reentry. One of the early requirements for us as a business was make sure we don't have a bunch of stuff hitting the ground.
Right.
The capsule will then re-enter at about Mach 20 and start to slow down as it goes through the atmosphere. At about Mach 1.5 to 1.8, we pull our supersonic drogue parachute. This parachute, again, developed in-house, is designed to quickly slow the vehicle from Mach 1.8 down to about Mach 0.2. That transonic regime is kind of the death regime for space capsules. They like to be very unstable during that. They start to tumble. This has happened with a lot of NASA vehicles, and hence why we have that parachute on board. And then once we slow down, we pull our main parachute and we touch down off the coast of California. Objective is, end to end, we want to have a success, but as with anything in space, first missions are high risk. So our goal here is to learn as much as we possibly can. We have a ton of sensors on board. All of this is focused on taking the learnings from Ray and applying them to ARC. Right? Ray was never meant to be a product. It's always been a technical development. So all of the systems are architected in the same way that ARC's systems are. So the same type of propulsion system, the same type of thermal protection material, the same types of parachutes. And so our goal here is learn as much as we can and apply that learning to ARC to better serve our customers.
You've talked several times about building almost all of your components in-house. How does that affect the company's innovation and production capabilities?
Yeah, so I think one of the things that a lot of space companies, at least historically, have missed is the need to scale production and why that's so important. There have been a lot of companies that race to get to first launch, and that's great. Yeah, you need to move as fast as you can. But then if you can't scale production and ride the cost curve of production down to where it's actually competitive in the market, your company will die. Right. And we've actually seen that with a number of different organizations. And so from day one, we basically asked ourselves, okay, how do you get to that production level fastest? Right? How do you get to the ability to bring costs down the fastest? Right. Let's assume for now you can build the technology and you can raise the money needed and you can get to first launch. Right. That's not the hard. The hard part is building the sustainable business after. Hence why we've decided to bring everything in-house, or almost everything in-house. Not only does it allow us to get to production quicker, it allows us to build it in a way that fits our requirements. A little bit of context, right? If I'm company A, and company A is a component supplier, they sell rocket engines or parachutes or something like that. They have to build a product that's able to reach a large market, right, in order to justify the cost of developing that. And so they have to have it so that that product can serve many different customers, meaning that the requirements on that product are quite broad, right? It has a large operating window. And that generally means that it's more expensive, right? Generally means that it has more capability than one customer may need because it has to serve many different customers. And so that on top of the extra margin that any business would put in results in that product being substantially more expensive than if you were to build it for a single application. And now a lot of folks will go with that. We buy a lot of our valves, for example, because it makes sense. But let's take the rocket engine, for example. Our rocket engines are designed to not be the most efficient thing ever, right? We don't totally care about efficiency, right? I mainly care about cost, right? I care about development timeline. I care about reliability for our customers. And so we focus on that level of development, right? We can detune a lot of our subcomponents to better fit into a holistic product, which reduces the cost. I don't need exotic materials for my rocket engine because I don't need the performance of those exotic materials. But that wouldn't fly for a broad market, and hence why a lot of the component suppliers will go to that high performance level. And so by building in-house, we can kind of reduce the requirement set, making it so that the actual individual components are cheaper than what it would be if you were to buy them later. From an innovation standpoint, our perspective is that innovating on technology for the sake of innovating on technology is not a good plan. Having a cool, flashy, like we build this type of tech is not something we're focused on. We focus on, does it impact our customers, right? Does improving this and innovating on this specific thing, whether it be the parachute system or the engines or the thermal protection material for our vehicle, does that help our customer? And if so, great. We'll spend time and resources to make it better. But for the most part, like most of the vehicle just kind of needs to work, right? It just has to do like roughly what it's supposed to do. And then there are a few things that are important, right? That would be landing accuracy. That would be getting down to the ground quickly, the autonomy. And so we spend a lot of time and effort on making sure that those are as good as they can be and building the infrastructure inside of Inversion to allow us to continually innovate on those products.
When you talk about the autonomy, does that work in that you have a customer that has whatever it is that you have in space, and suddenly they say, oh, I need a load of medical supplies at these coordinates in an hour and a half. Do they, for lack of a better analogy, go online and say, send it here now? Or do they come to you? Or how does that all work?
Yeah, absolutely. So our customers will basically give us a GPS coordinate and what cargo they want to carry. And then our software decides which capsule in space is closest, which will get there the fastest. It sends those coordinates, and then the vehicle then calculates its trajectory to where it needs to re-enter, how it needs to fly, et cetera, and then is able to land. So once we send the coordinates, we're hands off, right? We can intervene should we want to. There's safety systems. There is flight termination systems. We can update the landing coordinates. But our goal is give it the location, and then it goes and lands.
Fire and forget.
Exactly. And it turns out that people may be familiar with autonomous cars, right?
Mm-hmm.
And that's been a very hard journey for a lot of these companies to develop the autonomous driving technology. It turns out that when you're flying through the atmosphere, there's a substantial less number of obstacles that pop out randomly that cause problems. Like we don't have kids running across the road that we have to avoid. So just as like autopilot on an aircraft is relatively reliable because you have to go straight and correct it. Our vehicle is able to do a similar thing.
What role, Justin, do you see Inversion Space playing in the future of national security efforts? You've talked about that being one of your primary concerns going into this project. How do you think you're going to be able to affect that?
Yeah, well, if you look across history, it often is the case that the country that embraces the leading transportation system of the time is the preeminent or dominant country of that era. Ocean-going ships, horse and chariot, airplanes 100 years ago. And what do all of those have in common? Well, they are able to move faster than the adversaries of those organizations and have broader reach, right? Allowing one to expand its influence. Whether it's used or not, it is a deterrent that they could. One of the things that we noticed was that that can happen in space, right? Yes, people talk about national security efforts in space, of space to space problems, right? Or conflicts. But when we realized that hey, space is just like it's very easy to store stuff in there, and if you can bring it back, you can access the whole globe in under an hour. Well, that's a fundamental step change in how humanity thinks about transportation and storage, right? Today, even some of the most rapid response groups of the military are tasked with a 15-hour global response time, right? And they're like, this is amazing. Well, what about 30 minutes, right? What about an hour? And so, we can predict a lot of what will happen early on, next 5 years with this capability, right? You're going to deliver medical supplies. You're going to deliver sensors to, understand what's happening in an area. You're going to deliver drones to do surveillance or something like that. But it's hard to imagine what happens in 10 or 15 years, right? Or 20 years. Just like it was probably hard for people 100 years ago to anticipate what is the aircraft going to be used for, right? If you showed someone 100 years ago an F-22 fighter jet, they'd be like, this is magic, literally magic. And so, what we provide is faster access and broader reach to the globe. And a fundamental principle of warfare is if you have those two things over your adversary, you are highly likely to win. And so, we want to make sure that the U.S. is the group that gets that first.
Mentioning that 10 to 15 year time frame, and we are just about out of time, but we ask this question of all of our guests, Justin, and that's to look at over the next 10 to 15 years in space commerce and the role of the inversion you think is going to play in that, and tell me what you see. Yeah.
So, a couple things. One is I think launch costs are going to continue to come down. SpaceX is the, dominant player right now, but frankly, they have no incentive to reduce their prices today. They're probably making a massive margin on Falcon 9. You have a lot of competitors coming in. That's going to drive costs down just due to competition for launch. Forgetting about Starship for a second, right? Just competition is going to drive costs down. We've seen that the space market is highly elastic as launch costs come down. It has about a 5-year lag time or so. And so we'll start to see, things like inversion coming online in 2 to 3 years that takes advantage of that. I think that people are really realizing that a great space business needs to sell to folks on Earth. Right? The space economy is not yet large enough to sustain a massive, multi-billion-dollar business purely on in-space applications. And that might change over the next few years. What we hope to do is use the platform of space for terrestrial application, bringing the cost down of operating in space, right? By us flying often will reduce the launch cost because there'll be, higher volume. We're able to use our vehicle for a lot of in-space applications. I think we're at the early days of the internet, where there were a cool 2 or 3 cool things you could do with it. But as soon as social media popped up, right, it was okay, now we understand the business, right? Or as soon as Google search popped up, it's cool, there's a whole new business model. And we want to introduce that new business model to this platform of space of, helping people on the ground and moving very quickly to do so. So where are we in 15 years? I think it was hard to predict where we'd be 15 years from now, but probably launch costs trend to zero. And our hope is that space is used to store cargo and deliver it wherever and whenever you need in under an hour.
Sounds fascinating. And I'll look forward to getting that space capsule being dropped in my backyard with my widget from Amazon.
Exactly. It's going to be great. It's going to be fantastic.
Justin, we're out of time. Thanks so much for talking with me today.
Yeah, thank you for having me. I really appreciate it.
Justin Fiaschetti is the CEO of Inversion Space. And that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Google Podcasts, Audible, and many other popular podcasting platforms. Be sure to click subscribe so you don't miss any of our podcasts or any of our other videos. You can get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on X at XTerraJSC. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers, my Galileo through his looking glass. Thirst for reason. Our dreamer's eyes we gaze into a sense of purpose known by few. Like finding water on the moon.